If you are, the kind of person who loves building apps, you probably have this deep, passionate hatred for the first 3 days of any project.
Oh, absolutely. It is the worst.
Right, because you just want to get to the good stuff, like the actual building part. But instead, you are just stuck in this configuration purgatory.
Yeah, completely stuck.
Well, today we're exploring a tool that is trying to fast forward you right past all that busy work. It's called FlutterSeed.
Which is super interesting.
It is. And for this deep dive, we are pulling insights from two internal documents. We've got their project overview and the visual Flutter app initializer documentation.
Right.
Our mission today is to figure out how this platform is attempting to completely eliminate boilerplate, like taking days of mind-numbing project setup and turning it into a matter of minutes using a visual drag-and-drop system. Okay, let's unpack this.
Yeah, so we have to start by diagnosing the disease before we can truly appreciate the cure here.
Fair point.
The core issue FlutterSeed is tackling is that starting a new Flutter project from scratch is just a massive repetitive time sink. I mean, the sheer volume of manual configuration required before you can even begin to write a single line of actual product feature code is staggering.
To put that in perspective for anyone listening who, maybe might only code as a hobby or maybe you manage developers, starting a new project without a tool like this is a lot like buying a new house.
Oh, I like this analogy.
Yeah, so you finally get the keys, you walk through the front door, and you are so incredibly excited to start decorating.
You want to put up the curtains.
Exactly. You want to arrange the furniture, pick out paint colors, hang your art, which in app development terms means building the actual screens, the buttons, the features your users are going to interact with.
Right, the stuff people actually see. But the reality of software development is a very rude awakening from that dream.
A completely rude awakening. Because instead of decorating, you walk into your new house and realize you have to spend your first 3 days down in a dark, damp basement. You are soldering copper pipes for the plumbing, and you are stripping wires to build the electrical panel completely from scratch.
And in the Flutter ecosystem, that plumbing and wiring is the foundational architecture.
Right. You're burning hours, sometimes entire days, just setting up your routing engine with a package like Router, just so users can navigate between screens.
And you are agonizing over state management. Right.
Exactly. Wiring up Riverpod or Block just so the app remembers what a user clicked. You have to connect your backend, dealing with security rules for Firebase or Supabase. You are building out 10 empty folders just to establish a clean architecture. It's exhausting before the work even officially begins.
It's an incredibly frustrating bottleneck. It just kills momentum. And there's a term for the long-term consequence of this manual ad hoc process. The sources call it setup drift.
Setup drift. Let's break down the actual damage that causes because it sounds like a creeping problem rather than like an immediate one.
It is, yeah. It is a massive structural liability, especially as teams grow. Setup drift happens because every time a developer starts a new project or, every time a new hire joins an engineering team, those manual foundational decisions get made slightly differently.
Oh, right. Because everyone has their own style.
Exactly. Imagine an agency building multiple apps a year. Developer A might organize their architecture using a feature-first approach with Block for state management.
Okay.
Then 6 months later, developer B starts a new client project, but they prefer a layer-first approach and use Riverpod.
Right. A completely different foundation.
Fast forward 2 years, and that agency has a portfolio of apps that look completely different under the hood. When a bug needs fixing, a developer has to spend hours just relearning the weird bespoke architecture of that specific app. You lose all consistency because the foundational layer was never standardized.
And I know firsthand that the common workaround developers use to fight this is almost worse than the disease.
Oh, the starter repo.
Yes. You, as the listener, can probably picture this. To save those 3 days of initial setup, a developer will just copy an old, dusty starter repository from a project they finished a year ago.
Right, just clone it.
They clone it, they delete the old client's logos, and they think they just saved a week of work. But what actually happens? You end up inheriting a bunch of obsolete code.
Yeah, you pull in outdated package versions that immediately throw warnings.
Exactly. You drag along somebody else's weird structural choices or hot fixes from 2 years ago that make no sense in the context of the new app. You are essentially trying to build a modern, high-performance application on top of a decaying foundation.
Which brings us to the core challenge FlutterSeed is attempting to solve here.
Right.
How do we automate this repetitive time sink? And how do we standardize the foundation without falling into the classic trap of rigid, unusable generated code?
That is the million-dollar question, and it's exactly where my skepticism alarm started ringing loudly.
Yeah, I bet.
Because traditionally, in the software development world, generated code is treated like a dirty word. It usually implies this messy, unmaintainable spaghetti code.
Right, the stuff no one wants to touch.
You log into some visual app builder, you drag a few buttons around, and it spits out a file with 10,000 lines of absolute gibberish. The second you need to customize something or step outside the bounds of the visual builder, the whole app shatters.
It just breaks completely.
Yeah. No self-respecting developer actually wants to maintain that long term. So I'm assuming FlutterSeed isn't just mashing text files together and hoping for the best. Is it building some kind of strict blueprint first?
You nailed the exact mechanism they are using to avoid that spaghetti code trap.
Okay.
It is a highly structured, deterministic generation pipeline. Let's look at the front end first.
Sure.
The dashboard is built using Next.js, and the visual engine powering it is React Flow.
Let's pause there for a second to clarify React Flow for the listener. From what I understand, that is essentially the industry gold standard for building those really smooth, interactive web interfaces where you have different nodes.
The little boxes, yeah.
Right, little boxes on the screen, and you draw physical lines connecting them.
That perfectly describes it. On this digital canvas, every single architectural choice you make is represented as one of those visual nodes.
Okay.
Your state management package is a node, your routing choice is a node, your back-end connection is a node. You drag them onto the screen and wire them together. But that visual graph is not just a pretty picture. It translates in real time into a strict data structure called a scaffold config.
So the scaffold config is the blueprint. It is a mathematical representation of the app's foundation.
Exactly that. It is a predictable configuration file. Once your blueprint is ready, it gets fed into a handlebars templating engine.
Handlebars, okay.
Now, unlike artificial intelligence code generators that try to guess what you want and sometimes hallucinate weird errors, handlebars is purely logic-based.
Right, it doesn't guess.
Exactly. It's a templating system that uses pre-written, perfectly formatted code files with blank spaces in them. The engine simply looks at your scaffold config blueprint, takes the exact parameters you chose, and slots them flawlessly into those blank spaces.
Wow.
Because it is deterministic, meaning the same inputs will always produce the exact same outputs, the generated Dart code is exceptionally clean.
It's predictable, safe, and entirely free of guesswork. And one detail that jumped out at me to prove just how clean this output really is, the generated code passes Flutter lints right out of the box.
Which is huge.
Huge. For the non-developers listening, Flutter lints is essentially the official, strict rulebook from Google for writing standardized Flutter code. It checks for formatting, potential bugs, and stylistic consistency.
Right.
If a project passes those rules without throwing a single error, it means the code isn't just functional, it is structurally sound. It is exactly what a meticulous senior developer would write by hand, but it is generated instantly.
It enforces opinionated but highly logical defaults. I mean, the engine automatically handles the folder structures. It sets up the environment variables so your API keys are hidden.
Oh, it's so nice.
Yeah, it configures the debugging logs and handles platform-specific tweaks for iOS versus Android. All of that plumbing is done flawlessly.
Here's where it gets really interesting, because the developers behind this tool clearly understand their audience. You are not locked into using a browser-based drag-and-drop tool if you don't want to be.
Right. They know devs love the terminal.
Exactly. They built a dual interface. Sure, you can use the visual canvas on their website. But if you are a terminal junkie, a developer who hates taking their hands off the keyboard and wants to stay locked in their flow state, they have the FlutterSeed CLI.
The command line interface.
Right. You just open your terminal, type FlutterSeed in My App, and run through an interactive workflow right there in your shell.
That's awesome.
You use your arrow keys to select your routing, your state management, your architecture. Once you hit enter, it generates a secure download link, pulls down a zip file of your custom scaffold directly to your machine, and unzips it. You never have to open a web browser. It completely respects the developer's preferred environment.
And if we connect this to the bigger picture, the implications of this clean, deterministic generation change dramatically depending on the scale of the team using it.
Oh, for sure.
Because the output is genuinely production-ready, FlutterSeed ceases to be just a neat little utility for a solo developer trying to save a weekend. It transforms into a structural foundation that scales all the way up to enterprise organizations.
Let's actually walk up that ladder, starting with the indie developer or the freelancer.
Yeah, for the solo developer, the value proposition is pure, unadulterated speed.
Right.
The workflow shifts from a 3-day slog of configuration to a 60-second architectural decision process. You select your nodes, download the scaffold, run the Flutter run command, and you are immediately building the minimum viable product.
Which is money in the bank.
Exactly. When you are a freelancer billing by the hour or trying to get a product to market before a competitor, deleting 3 days of dead time from every single project is a massive competitive advantage.
But saving time for a solo dev is really just a drop in the bucket. The real chaos this solves becomes apparent when you scale up to a startup or an agency. The value proposition shifts entirely away from raw speed and focuses heavily on curing the onboarding headache.
This circles back perfectly to the setup drift problem we diagnosed earlier. In a fast-paced agency, developer turnover is normal.
Oh yeah, constantly bringing new people on.
Right. But when a new engineer joins the team, they often spend their first 2 weeks doing nothing but reading old code, trying to decipher the ad hoc patterns the previous developers cobbled together. It is a massive drain on payroll.
Definitely.
FlutterSeed allows an agency's lead architect to create a standardized team preset.
I can see how powerful that is. Instead of a senior developer sitting down with a new hire and saying, hey, go read these 10 different code bases and try to guess our style, the onboarding becomes start every new client project using our agency's official FlutterSeed template.
Yep.
It mathematically guarantees that every single developer in the building is using the exact same state management, the same routing protocol, and the same clean architecture principles from day one.
And the scaling doesn't stop there. When you reach the enterprise level, the challenges become exponentially more complex. At that scale, it is about codifying defaults across dozens of internal and external applications simultaneously.
Wow.
It is about standardizing the overall folder structure so any engineer can jump into any project company-wide and know exactly where the database logic lives. It also tackles massive UI challenges, like implementing dual palette theming right out of the gate.
We should definitely explain what that means, because dual palette sounds like a design term, but it is actually a massive technical headache.
Oh, it really is.
We are talking about Material 3, which is Google's latest, highly complex design system. Building an app that flawlessly switches between light mode and dark mode while respecting a brand's specific color guidelines is remarkably difficult to program from scratch.
So tedious.
Doing it manually across 50 different enterprise apps usually results in weird graphical glitches where dark mode has unreadable black text on a dark gray background. By having dual palette theming baked into the FlutterSeed generation, an enterprise guarantees perfect light and dark mode compliance before a single line of custom logic is ever written.
And to make all of this immediate, the platform doesn't force you to start with a blank canvas and figure it out yourself. They have curated presets built right into the engine.
Nice.
For instance, there is an e-commerce starter that gives you the specific structural foundation needed for shopping carts and product catalogs. There is an offline first template, which comes pre-configured with a package called Hive.
Oh, Hive is fantastic. For the listener, Hive is a lightning-fast local database. If you are building an app for field workers who might be out in the mountains without cell service or users on a subway commute, Hive lets the app store all that data locally on the phone and sync it up later.
Which is usually a nightmare to set up.
Right. Wiring that up manually is incredibly tedious, but as a preset, it is just ready to go.
Precisely. They also offer an auth-only template for apps that just need secure login flows and a full-stack Supabase template. Supabase is an open-source backend as a service. It gives you a Postgres database, authentication, and edge functions.
Yeah, Supabase is super popular right now.
It is, but normally connecting a Flutter app to Supabase requires extensive boilerplate to handle the security tokens and API calls. With the preset, that entire bridge is built and secured automatically.
The genius part, though, is that these aren't rigid templates that trap you in a box. You can fork these baseline presets. You can take that Supabase template, pull it into your visual graph, and start customizing it.
You're not stuck at all.
No. You can drag in custom nodes, or even pull in specialized packages directly from pub.dev, which is the official package repository, where the global Flutter community shares their code, and integrate them right into your visual setup.
That flexibility is what separates a gimmick from a professional tool. But looking beyond the professional workflow, there is another layer to this platform that fundamentally alters how developers interact with the ecosystem.
Yes.
Yeah.
This is the angle that completely caught me off guard. Obviously, everything we just discussed proves this platform is built to optimize the workflow for seasoned pros and massive corporate teams. But it has this hidden superpower that kind of flips traditional tech education completely on its head.
What's fascinating here is how the platform inherently acts as the ultimate learning sandbox for beginners.
Yeah.
When you are first learning software development, the hardest hurdle isn't memorizing the syntax of the language. The hardest part is understanding the architecture.
Like how all the pieces fit together.
Yeah. Exactly. It is trying to visualize how the routing package talks to the state management package,
Right.
and how that talks to the database in a real-world production environment.
Because traditionally, the way you learn that is by reading a tutorial. And reading a tutorial is an incredibly passive experience. You are just absorbing someone else's explanation of how things should theoretically fit together.
And half the time, it doesn't work.
Right. You copy and paste their code blocks, and if it doesn't work, you have no idea why. But FlutterSeed makes the learning process entirely active. You are generating the structural code yourself based on deliberate decisions you make on the visual graph.
The implication for a junior developer is profound. If they want to learn clean architecture, or if they are confused about the practical real-world difference between using Block versus Riverpod for state management, they don't have to rely on a 30-minute YouTube video.
No, they don't.
They can literally generate the code for both approaches and see the architectural differences in action.
To me, it is the exact equivalent of having a senior veteran engineer sit down next to you and build the exact same app two completely different ways just so you can compare their homework.
That's a great way to put it.
You open up the Visual Builder, you drag the node for Block onto the canvas, wire it up and generate the app. You download that zip file, then you simply swap that one single node on the graph to Riverpod, and you generate a second app.
Just boom.
Put those two folders side by side on your monitor, open them up in your code editor, and you can see line by line, file by file, exactly how a production-ready implementation differs between the two approaches. It is a real-world, interactive sandbox.
It completely bridges the gap between theoretical knowledge and practical application. You can physically trace how the routing files, the dependency injection, and the back-end connections all adapt and shift when you swap out one core component.
Yeah, seeing it is believing it.
And you know the code you were reading is flawless because the Handlebars templating engine dynamically rewires the architecture perfectly each time.
So let's bring all of this together and look at the big picture. The core value proposition of FlutterSeed is that it functions as a highly advanced visual scaffolding engine. It takes that deeply painful, manual boilerplate phase of starting a new app.
The copper pipes and electrical wires.
Exactly, the copper pipes in the dark basement. And it replaces it with a deterministic graph-first configuration. Whether you prefer the visual web dashboard or the fast-paced CLI in your terminal, it allows you to assemble your foundational architecture visually.
Yep.
It mathematically guarantees clean lint passing code, so you can actually start shipping your project in minutes instead of days. And it does this whether you are a solo indie dev trying to save time or a massive enterprise team trying to cure setup drift.
It's a game changer.
It really is. So what does this all mean? Where is a tool like this actually heading in the next few years?
Well, this raises an important question, and it builds on a very specific capability we discussed earlier. We know that users aren't limited to the default nodes, right? They can pull custom packages from pub.dev and add them to their visual graph.
Right, they can expand it.
But what happens when the global community of developers starts saving, refining, and sharing their own highly complex custom node graphs?
Oh, wow. That changes the ecosystem entirely.
It really does. If the community can easily share these visual blueprints, could a tool like FlutterSeed eventually evolve into an open-source visual marketplace for entire app architectures?
Yeah, I mean, it's possible.
Right. If a junior developer can just download a top-tier expert's visual graph and instantly generate a perfect, customized, production-ready code base with all the complex wiring already solved, does that eventually make traditional written coding tutorials entirely obsolete?